Hello, I'm Stefan Greber, the project leader for LXD, and in this video I'm going to be looking at how LXD works with images. As you know, LXD is image-based. Every single instance, whether it's a container or virtual machine you're creating, will normally be created from an existing image of a pre-installed Linux distribution or the operating system. That's usually downloaded from a public image server, unpacked, and then you get in there and you install whatever you want. There's also the possibility for you to build your own images from scratch with a variety of different tools. And also the ability to republish any instance you have as a fresh new image. LXD also technically supports creating an instance completely blank, not from any image. That's particularly useful for virtual machines because it then lets you boot from a CD-ROM drive, like an ISO image effectively, or even netboot and install things that way. It's also possible for containers, but it's a lot less useful there because you typically then have to go and populate the root file system yourself, either through our file transfer API or manually on disk before you get anything that's actually functional. All right. So first thing first, let's just take a look at how the public image servers work. LXD effectively has two main one of those. The main one is run by the LXD team directly as a community image server. That's what's seen as images : as far as the remote inside of LXD. The other main one would be the one run by the Ubuntu team. So the Ubuntu cloud team runs their own image server with officially tested Ubuntu images. At this time, we don't have any other distribution doing the same, but we're definitely open to have more official images from other distros that are, tested and validated on their side prior to making it to our users. For the community image server, it's at imageslinuxcontainer.org, and we can see the list of all the different images that we publish on a daily basis. I don't remember the current count. I think it's something in the neighborhood of 350 to 400 images a day that we are building and publishing. Those images are then made available over simple streams, which is effectively a JSON type index file that LXD can download and interpret to know about all the images available on the server. So this image server is effectively a static web server. There's no live API or anything going on there. Same thing with the image server that the Ubuntu team runs. If we go there and look at the releases, which is the mainstream, there's gonna be a folder here called streams v1, and those are the index files. So LXD would load that index.json here, and then based on that information, we'll go look at the download JSON, which lists all of the different image files and their fingerprint and everything. There are like a number of fields in there that are LXD specific. We can see the LXD metadata tarball. So that's how LXD effectively works with the public image servers. There's no actual communication back and forth. We just download an index file and then compute a list of all the images available from that server and download what we need. All right, so now you can go look at the way LXD actually handles those downloads. So if we move to a basic LXD server here, so it's actually a blank machine, so it's going to be installing LXD from scratch. And so it's going to get us LXD probably 5.2 at this time. And then we'll go and see what LXD does the first time you create an instance from an image. Because LXD effectively has a built-in image server. And so when you're downloading an image from an external server, like our public image servers, those images get downloaded by LXD into its image server first. And then the instance will actually be created from that as a second step. And any additional instance you're creating then doesn't need to download the image from scratch again. Now let's just configure that server real quick. I'm just gonna go run through LXD init and just pick all the defaults. So it's gonna get us a ZFS based setup. There we go. All right, so now if we just start, say, Ubuntu 22.04 as a container called U1, you can see that it's retrieving the image right now. So it accessed that simple streams index I was mentioning. It figured out what's the latest image for Ubuntu 22.04 for the current architecture, in this case, Intel 64-bit. The image is being downloaded, it's being unpacked. And once it's actually being unpacked into, in this case, a ZFS volume, making it possible to very, very quickly create another instance. So if we do that, it didn't need to download anything. It created it very, very quickly. And we also don't want to re-download those index files all the time because they're reasonably large. So they're actually cached on disk for a few hours before we re-download them. So if we go look at our snap LXD, command LXD cache, we can see there's a cache here of those indexes. Now we've got two instances created here. And if we look at the local image store, you can see there's one image in there. It's just a fingerprint, doesn't have a name, doesn't have anything. The image is kept private. It's for a container. And if we go look at details on the image, it tells us some properties of that image. So in this case, it's Ubuntu, it's jammy, so Ubuntu 22.04. And it came from the images-container.org server. The protocol it used was simple streams, and the alias that was used to fetch it was Ubuntu 22.04. So that's effectively kept inside of LXD's database. Can also see that the image is marked as being cached, and it's automatically updated. What that means is every 6 hours or so, LXD is gonna go and look, so effectively fetch the index again from that server, and see if that alias points to a different image. If it points to a different image, that image will be downloaded and will replace the currently cached image that we have with the whatever is the current target on the server. This works pretty well because it means that we already have the image downloaded. So if you want to like if tomorrow you launch a new instance, it's still going to be Ubuntu 22.04, but it's going to be the latest build of Ubuntu 22.04. You don't need to go and refresh images or do any of that kind of stuff. It won't download it at the time you request it. Tomorrow it's already going to be there. But that can be quite wasteful. So there's actually a second mechanism for any image that was downloaded as part of an instance creation request, as was the case here. There is this cached flag being set to yes, and LXD keeps track of when an image was last used, so the last time an instance was created from it. And after 10 days, which is a default configuration, any cached image that has not been used over the past 10 days gets automatically deleted so that we stop updating them. It's also worth noting that some image servers, especially the one that we run, the community image server, supports binary deltas. So when it actually downloads tomorrow's image, it's not going to download the entirety of tomorrow's image. It's actually downloading a binary diff between today's image and tomorrow's image, and then applies that diff. That allows for much smaller updates to images, so that it's a lot less intrusive and uses a lot less bandwidth for our users. So that's how things normally work with a public image server. As I said, you can also create your own images. And the way you effectively do that is get into an existing instance, do some kind of change. So let's say we just hello world inside of root foo. Okay, then we can stop that instance and can do publish u1 alias my image. And what LXD does now is it actually compacts the entire file system of that instance into a new image tarball that it then will hash to generate the image fingerprint. So that's what we see on the normal images. That hash is effectively the hash of the data, so the compressed image. Okay, so it did that now, and then that shows up in our local image server, so image list. now shows a new image here called my image. With its fingerprint, it's still a private image. So if we do launch and we just do my image view 3, now it's unpacking that image for local consumption into our storage pool, so into ZFS in this case. And once that's done, it will create an instance from it. And we should see that it has our change. So root foo has hello world inside it. So that's how you can pretty cheaply create your own images. There's obviously always a bunch of extra steps to be very, very careful about when you're creating your own images. Like you don't want there to be any kind of unique information. So say if you got like a machine ID, an SSH host key, any of that kind of stuff, you want to strip all of that out prior to publishing, because you don't want every single instance you create from that image to have the exact same SSH host key. That would be very bad for security purposes. Same thing with the machine ID, which is consumed by things like dbus and MDNS. You don't want to have multiple of the same machine ID on the same network. That's going to cause problems. So there's a few more steps you need to be careful of when you're creating your own images that way. Anyway, that gives us an image. The other way you could do it is the same way we do for our own images. So we've got that repository called distro builder. That can be installed as a snap as well, or you can build it from source. It's a tool that's the tool we use to generate all of our different images, and there are quite a few of those, as you've seen earlier. We've got configuration for it in a separate repository, the LXD CI repo, which then has images directory with YAML definitions for every single one of them. So I don't know if we take Arch Linux, can see we've got the GPG key that's expected for the repo that we're downloading some artifacts from. Then there's some stuff in here that's actually just for LXC, so not for LXD, but those images are also usable for traditional LXC users. And then a number of files that need to be customized and templated, things like the host name, hosts file. In the case of VM, we need to do some tweaks to grub, to the network config, a bunch of other things. And then you get to the more interesting bits of like, okay, what packages do you want to see installed in there? And then there's going to be a number of scripts and actions that are being run at different stages of the build. And that's what we use to generate all of our different images. The YAML lets us easily like restrict things on a specific variant, or architecture, or different type of images as well. So that's what we're using. Another thing that lets you really build your image completely from scratch. That's not always what you want to do. If you just want to repack an image and like install a few more things on top of an official image, you can either do what I did earlier with just doing it through LXD, but you like it's a bit more manual. You need to kind of do it through LXC exec and LXC publish, or you can use a tool like Packer, which supports LXD as a build target effectively. And using Packer, you can also through YAML kind of define all of the scripts that you want to run, all of the packages you want to install, and it can generate effectively a repacked image for you that way. In our case, DistroBuilder is also run through Jenkins. So our Jenkins instance has all of the different builds. We can see that some of them are failing, some of them are being retried right now. If we take again Arch Linux on here, we can see that Arch Linux is being built on Intel's 64-bit, ARM 32-bit, ARM 64-bit. We do 3 different variants, including a desktop build, a VM desktop build. And then most of those actually built as both containers and VMs. And you can see here the resulting artifacts for that image include a QCOW2, so that's for virtual machines, as well as rootfs, squashfs, and LXD that are used for containers. And you can go look at the build log here and see exactly like what's being passed and the output of DistroBuilder and all the commands being run, leading to the image being compressed and extracted from the build environment. All right. Can go back here. And so that's all of the image building side of things. That's really kind of how to build your own images. Distro Builder is pretty convenient because it already knows about LXD images. Same thing with Packer. If you just republish your existing instance, there are a few things to be aware of. You may also need to use LXC config metadata edit, so you can change some of the image metadata prior to actually publishing your image. And the bulk of that is covered in that documentation we've got here about image handling. The other side that I wanted to cover with this video is actually how do you run an image server. As I mentioned, our public image servers are a bit special because they are not using LXD. They're static image servers, so static web servers with just a bunch of JSON that LXD downloads. That's fine, and you can definitely do that yourself. There are some people out there that wrote some tools to help you with that. But that's not the easiest. So how about we go look at what's the easiest. So I've got a second server here called image server. I'm just gonna zoom things again. Okay. All right. So if I go in that other server called image server here, and similarly, let's install LXD. What the role of this server is that it will run LXD, but it will not run any actual instance. So that's something LXD can do. Every single LXD server is an image server. All you need to do is to have it listen on the network, and then any image in its image store that's marked as public can be downloaded by anyone, and images that are marked as private require effectively authentication to access them. So that's what we're going to be seeing in just a few seconds here. All right, now that LXD is installed, let's do LXD init. So I'm just setting it up with the most basic of setups here. It's actually doing slightly more than I need because it's creating a network, which we were not gonna need. But with that, we've got some storage in place, and that's pretty much all we need. So if we look at the image store right now, there's nothing. So let's just try to do something pretty simple, and we're gonna copy in an external image. So say Ubuntu 22.04. Gonna copy that to the local image store, and we're gonna call it Ubuntu-22.04. So, okay, that's done. And now we can see the image is in the image server, but it's currently listed as public now. So that wouldn't actually be accessible for anyone else. Anyway, before anyone else can access that image server, we need to make it visible on the network. So we can just set it to listen on all addresses on the standard port. Then we need to find the IP address of this instance, which is that. And here we're going to do, let's see, remote add my images and then the IP address. And you notice that in this case, it's asking for a trust password, but we can just treat it as a public image server by doing --public, which then adds it immediately. And that lets us actually list the images that are on it. And we're going to see nothing right now. That makes sense because there's no public images. Again, if we look down here, the list of image only has one image and it is not public. We can fix that with image edit Ubuntu 22.04 and changing the public here to true, saving, and now sure enough we can see that image, which then lets us do launch from my images Ubuntu 22.04 U4. And now that container was created from that image. It was very, very quick in this case because we already had the image locally available because it's the same image we keep using. But I could do the same thing here. Now, if I copy another image, say we copy Alpine Edge, and I'm gonna call that Alpine-Edge. You can actually mark it that you want it public during the copy, so that's the easiest. Okay, it's been copied. So now I can, from my images, I can launch from Alpine Edge, call that A1. And now it's done loading, but it didn't download from the public image server, it downloaded from our local image server. And then it launched it. And as far as this server is concerned, all of those images are still just remotely cached images. There's nothing special about them. But if we go look at LXD image info on that last one, the Alpine one, it does show that it came protocol LXD and it came from our own image server. Now, one trick we can do is if we do image delete Alpine edge, and now we copy something other than Alpine there. Well, I don't actually remember the release names for, but well, there's another Arch. Okay. So downloading an Arch image and publishing it as Alpine Edge, which is probably not a great idea, but that's done. And now if we look here, and we launch again from Alpine Edge, it used the cache in this case. So it just, the cache didn't expire. There's like a multi-hour cache to avoid those kind of things. But we should be able to refresh it. So if we refresh the, oops. I wonder if that's gonna hit the cache too. No, that's taking a while, that's good. So LXD image refresh is a command you can use to tell LXD that, like, regardless of the cache and its own background checks and all of that stuff, to go and look whether there's a new version of the image, and if there is, to download and refresh the entry that it has locally. So that's what's happening here. It's refreshing our Alpine Edge image. And if we go look at the result, the Alpine Edge image is now gone. So it was there, it's no longer here, but now we've got the Arch Linux images cached instead. Which means that if I do this, we should be getting an Arch Linux image this time. Yep. So that works pretty well. That's like for a lot of cases where all you want is really to run a local image server, either because you need to deal with firewalling within your company and only want one machine that's allowed to talk to the public image server, or because you want to gate images. That works really well. You can just take a random machine, install LXD. You don't need to really define any storage pools, networks, run instances, or any of that. Just have LXD there and then copy in images that you want, and LXD will be able to talk to that server and fetch images from it. There are a few more things you can do during an image copy. Go look at the help. You can see that it can copy aliases. So that would mean that it copies the aliases from the remote server. That's not really useful for your image server usually. But one thing that could be useful is auto update. So if we just clean things up a bit here and we delete that Alpine Edge and we copy the real Alpine image. Okay, so we can set it that way. And what that means, if we go look at the details on the image, is it's got its properties, it's got the alias we've set. It is not cached because we manually copied it, but it is automatically updated. So now that means that every 6 hours, this LXD image server is gonna reach out to the public image server, will look for any changes to the image, and if there's one, will download that image into its own server, which then means that my LXD server above here will then, probably 6 hours later or something like that, notice that the image changed and then refresh it. So that's really a way to effectively run a proxy, because you can copy in whatever images you want from our public image servers with the auto update flag set on to your local image server. It will automatically keep them up to date, and then all the machines you have locally that pull images from it will also refresh their own copy. Just to show you what that copy aliases function does, if we go look at this one. So if I do an LXD image copy from my images and let's grab Alpine Edge, local, and I do copy aliases, and let's also do, I don't know, what update for good measure. Now we can see that the Alpine Edge alias is also present locally. That then lets you do just this if you want locally, instead of having to pass in my images colon Alpine Edge. Most of the time, it's not really all that useful. The main reason why you would want to do that is if your system is often offline, whether like you're using it on a plane or somewhere that just doesn't have internet connectivity, because that lets you then easily launch instances without ever having to reach out to the external image server, which then works great offline. Otherwise, LXD will want to see whether the image that it has in its cache has changed to something else remotely, and it might try to connect, which could fail if you're offline. And I think that's it. It was, I mean, that video was slightly all over the place, it feels like, but hopefully it gave you a pretty good overview of LXD's image handling. Both how LXD consumes images, usually kind of what our different kind of image servers look like, and also how you can like run your own image server locally, either to reduce your total bandwidth usage, or to allow for like a semi air-gapped type mode where you've got just one server that can talk to the public internet and not the rest, or also for image gating, like the public image server, like the community image server that we run. Those images are not actively validated, like they're not gated on testing. We do run automated testing on them, but it's after they've been published most of the time. So if you're really dependent on LXD images, it might be a good idea to run your own image server and then validate that the images are like behave according to what you need, and then consume them from there. And this lets you do it pretty easily. It also hopefully kind of showed you a bit more about how LXD handles those cached images, the expiry and refresh, and how that works. In any case, if you've got any more questions around this, don't hesitate to first take a look at the documentation. There are a bunch of things on there, especially around the exact layout of the image files and all that kind of stuff, which I didn't cover in the video. So you can go take a look at that. And if you've got any more questions, feel free to leave them in the comment section below or on our community forum. And I'll see you in the next video. Thanks.